Okay. So I'll try to pick up where we left off, and we were just about to get to the second point. Okay, so here we go. So we finished doing the ones that look like this, where you simply had two variables, one's odd, one's even. Both could be odd, both could be even. You separate them, follow the rules for odd and even. So here comes the second part. Remember, there's three parts. So the second part is, well, just remember and recall that before we dealt with variables, we had square roots with non-perfect squares like 72, 75.
3, 2, 3 to Carline.
And remember, the process of this was we think about that box number one from that one section where I made you write down the first 16 perfect squares. And we think about the largest perfect square that goes into 72, and that would be 36. Remember, the perfect squares ignore 0 and 1, but we start with 4, 9, 16, 25, 36, 49, 64, 81, 100. So 36 goes to 72 two times. So 36 times 2 is 72. And the square root of 36 is 6. So we get 6 root 2. Same thing for 75. What's the largest perfect square? That would be 25. 25 times 3 is 75. And the square root of 25 is 5. So keep that in mind and think about what would happen if we combined what we just did with numbers with what we previously did with variables. So you would have a number and a variable inside of a square root symbol. So here's how you would, here's how we would handle this one. I'm not saying you have to write it like this, but it will help. Write this particular square root as two square roots multiplied together. So the square root of 12 times the square root of y to the fifth would be 12y to the fifth underneath the square root symbol. So if we separate those into two separate square root symbols, then we can treat each one separately. So I'll do the 12 first. We think about the first 16 perfect squares. What goes into 12? 4 does. 12 can be written as 4 times 3. Okay, cool. And y to the fifth, we follow the odd rules. So subtract 1, that's 4. Half of 4 is 2, so we get y squared and a square root of y. Now, the square root of 4, I'm looking at the square root of 4 times 3. The square root of 4 is 2, so that would turn into 2 root 3 with that y squared and y. And now it comes a new rule. So I have two square root symbols multiplied together. And the rule is you're going to treat the outside things, the things that are outside the square root, you multiply them together. So I say outside with outside. So I'm going to multiply the 2 and the y squared together and get 2y squared. And then the second part, I'm going to multiply the insides together. So these are the things that are underneath the square root symbol. That's a 3 and a y. And 3 times y is 3y. So that's your final answer. I'll show you that one more time. Same problem. Separate this into two problems. Take the square root of the first one. That's 12. Well, 12 is not a perfect square, so I need to write 12 as 4 times 3. The square root of y to the fifth, or 5 is odd. Treat the odd rule. 5 minus 1 is 4. Half of 4 is 2. So y squared, or y to the second power, comes on the outside, and a y. The square root of 4 is 2. And now we multiply outsides with outsides, insides with insides. So the things on the outside are 2 and y squared, so 2y squared. And the things on the inside, that means the things that are underneath the square root symbol are 3 and y. 3 times y is 3y. And that's your final answer. We'll do a bunch of these, don't panic. All right, so once again, separate this into two problems. Treat them separately. The largest perfect square that goes into 32 is 16. 16 times 2 is 32. B to the fourth, hey, it's even. Follow the even rule. We just take half. That would be b squared. The square root of 16 is 4, so we would get 4 root 2 times b squared. Outsides with outsides. Well, the outside with the first one there is 4, and the second one doesn't even have a square root symbol, so it would just be 4 times b squared. In other words, 4b squared, and well, there's nothing to multiply the insides with, so it would just be the square root of 2. All right, that one was pretty easy. I said we're going to do a bunch of these. Oh, we got two variables now. Separate it. All right, the square root of 25 is a perfect square. Square root of 25 is 5. Let's see, y to the 5th is odds. 5 minus 1 is 4. Half of 4 is 2. So we would get y squared and a y, and x is just x. So we're just left with x on the inside. There is no outsides to multiply with outside. There's no insides to multiply with it. That is the final answer right there. So there's nothing to do. 5 times y squared is 5y squared, and yx times yx is, or y times x is yx. There we go. One more. 80 is a hard one. Most people would say 4 times 20, and that's true, but the largest perfect square that goes into 80 is 16. So 80 could be written as 16 times 5. A squared and b squared are both even, so if we take half of those, we get a to the first, b to the first, or basically a and a b. Square root of 16 is 4 times ab. Now we can do outsides with outsides. 4ab, well, that's 4ab, and root 5. There's only one inside, just the square root of 5. Okay. Hopefully you're getting this 2 practice ones and we're done here. All right, so let's see, 28. That can be written as 4 times 7. Y to the 6 is even. Take half of that and we get to the 3rd. The square root of 4 is 2. Outsides with outsides. That would be 2 times y to the 3rd. That's 2y to the 3rd, and the square root of 7. There are no insides to multiply. Sometimes you don't have any outsides. Sometimes you don't have any insides. All right, one more. 45. I believe that's 9, right? 9, yeah, 9. 45 is 9 times 5. 3 is odd. Minus 1 is 2. Half of 2 is 1. So a on the outside, a on the inside, and b squared is even. Half of b squared is b. So I got a and a b on the outside and a square root of a. Square root of 9 is 3. Finally, I got some outsides and some insides. Let's see. Outside with outside, that would be 3 times ab. That's 3ab. Insides with insides, 5 times a is 5a. And that's underneath the square root symbol. And that's part 2 right there. All right, last part 3, right? Recall that 3 squared is equal to 9. And if I take the square root of 3 squared, well, the square and the square root are inverse operations. They cancel each other, and we're just left with that 3. Okay. Think about this, though. Negative, in parentheses, negative 3 squared, if I take the square root of that, well, let's see. If I square it, I get 9, right? Negative 3 times negative 3 is 9. So therefore, if I take the square root of parentheses negative 3 squared, well, the square and the square root would cancel. I'll be left with negative 3. So let me get this straight. The square root of 9, ask yourself what 2 numbers multiplied together are 9. And well, 3 is definitely one of those numbers. And we call that one the principal or the positive square root. But the square root of 9 could also equal negative 3. Because negative 3 squared is 9. Now, be careful. I'm not talking about this. What I'm not saying is the square root of negative 9 is negative 3. I'm not saying that at all, right? That will not be true. In junior year is when you find out how to take the square root of a negative number. And by the way, it still won't be negative 3. Will be the answer. It'll be a different answer, but you'll find out about that. Well, you'll find about this next year in Algebra 2. But what we're going to be doing today is we're going to be solving equations like this. In other words, equations that involve squaring. Well, let's see. How do we get rid of squaring? Well, let's see. There's 2 numbers that are squared. There's 9, 3, and negative 3. So if we take the square root of both sides, we get 2 answers. We get a 3 and we get a negative 3. They both equal 9. I'll tell you how this is done here in a second, but I just want you to understand that when we solve these problems, the ones where x is being squared, we're going to get 2 answers, a positive and a negative. So all we're going to be doing now is just solving equations. This year we've solved linear equations. Now we're going to solve some quadratic equations. Eventually, not this year, for next year when you take Algebra 2, you'll also solve when the power is to the 3rd power, but not this year. Don't panic on that yet. Remember, when you solve equations, you get rid of things, and to get rid of things, you do inverse operations. To get rid of subtraction, you add. It's the inverse. To get rid of multiplication, you divide. That's the inverse operation. And lastly, what we're about to do, to get rid of squaring, we take square roots. So that thing right there, that's what we're about to do. So how do you solve this equation? How do we get x by itself? What's attached to it? That 2. It's not attached through multiplication. It's attached by an exponent. It's being squared. And to get rid of squaring, we take square roots. We already know there's going to be 2 answers, a positive and a negative. So when you actually take the square root of both sides, when you take the square root of a variable, you have to include that the answer will either be positive or negative. And we have a symbol for that. That's that plus and minus symbol put together there next to the square root of 9. We read that as plus or minus the square root of 9. So when we take the square root here, the square root and the x squared, they cancel. The squaring and the square rooting cancel, and you're just left with x on the left. And on the right, the square root of 9 is 3. So we're left with plus or minus 3. And that literally means the answer is -3 and +3. Let's see that again. To solve this equation, we need to get rid of the 2. To get rid of squaring, we take the square root. There's going to be 2 answers. When we take the square root of a variable, we put plus or minus on the other side. That means the answer is either going to be positive square root of 49 or negative square root of 49. The square root of x squared is x. The square root of 49 is 7, so we get plus or minus 7. In other words, x is either -7 or +7. Now, those are the simple ones. The more complicated ones involve, I don't know, a little bit of stuff to it. So this one has a little bit of stuff involved. Same process. To get rid of the 2, we take the square root. So that means there's going to be 2 answers. That means we write the square root and is equal to plus or minus the square root of 20. 20 is not a perfect square. It's not like 25. But there is a perfect square that goes into 20, and that's 4. 4 times 5 is 20. The square root of 4 is 2. The square root of x squared is x. So we get is equal to, or x is equal to plus or minus 2 root 5. So that means there's 2 answers. X is either equal to 2 root 5 or -2 root 5. The more complicated ones are just as easy. They just involve more numbers to get rid of. So check this one out. I'm not going to take the square root first. I'm going to get rid of the -25 first. So to get rid of -25, inverse operation, we add 25. To get rid of squaring, we take the square root. But remember, when you take the square root of a variable, on the other side, we got to put a plus or minus. Plus or minus square root of 25. Well, the square root of 25 is 5. The square root of x squared is x, so we get x is equal to plus or minus 5, or x is a -5 or +5. We'll do one more, call it a day. So this is the most complicated one, and it's not bad at all. So I got to get rid of 2 of 2's and a -32. Which one is easiest to get rid of first? Than the -32, obviously. So let's get rid of -32. So we're going to add 32 to both sides. Now, I would not take the square root of both sides, although you could right now. I would get rid of that first 2. That first 2 is being multiplied by x squared, and we get rid of multiplication by division. So I would divide both sides by 2 first. The 2's would cancel on the left, and 32 divided by 2 is 16. Now, to get rid of that last 2, we'll take the square root of both sides, but you're taking the square root of a variable. That means there's 2 answers. That means plus or minus the square root of 16. Square root of x squared is x, and the square root of 16 is 4, so we get plus or minus 4, and that's the last one. So the worksheet that I gave you, 11.5b, those are the 3 things that we did. We did basically take the square root of some variables, more than one. We did take the square root of some variables and a number inside the square root where there's a perfect square hidden in there somewhere. And lastly, we solved simple quadratic equations. And that was what you missed from class. And I will see you tomorrow.